Hey, fourth graders.
Hi, fourth graders.
Welcome back to our science classroom. Yay. It's going to be a fun day.
We have a fun day planned.
Really fun day planned. But before we get into it, I'm going to take my glasses off because they're fogging. And so I'll just put them on when I need to read something. Let's check in with our zone. How are you feeling today? How's your body feeling? How's your brain feeling? How are your emotions feeling?
Well, teachers, what's your zones today?
Miss Roslyn?
I'm in the bluey-yellow zone today. I'm in the yellow zone because I have a lot of things that I am trying to remember, like just little things, appointments, and I was bringing some bowls today to TV classroom, and I just had a lot that I needed to remember. And I was worried that I would forget, and that created just a little bit of a headache right here. So kind of that's the blue zone part. How are you feeling?
Bluey-green.
Oh.
I'm good to go.
Yeah.
But I got one of those inflamed taste buds on the tip of my tongue.
That is so annoying.
So I might have a lisp today because it hurts really bad.
Oh.
So it's just sore.
Ouch.
It's kind of that, it's not like bad, it's just
Yeah.
annoying.
Yeah.
So that's the only blue part. The rest of it's green, and I'm really excited for our lesson today.
Yes.
Mr. Kevin, how are you today?
Well, Mrs. Wally will stay away from tongue twisters today, right?
Yeah, that's not going to work for me
Not
today.
a good idea for Mrs. Wally today. No tongue twisters. I'm in the green zone. I feel pretty good. Happy to be here. Ready to
Great.
learn.
Yes.
Awesome.
It's going to be a fun day.
So let's remind ourselves of our three personal standards. Today and every day when we come together, we agree to show respect, make good decisions, solve problems.
And we're going to be doing experiments today that you can do at home, which is really fun. But we're definitely going to need to show respect and make good decisions. And with experiments, we know we probably will have to solve some problems. There's already one I've been trying to solve, and we'll talk about it when we get there.
Yeah.
All right.
Okay.
Let's take a look at our observation. Get your science journal out. Get your pencil out. We're going to show you a video. Now, there's not very much sound in the video. It's in slow mo. But before we start it, just look at it. What do you notice is there? What do you see in the video? Miss Awesome, what do you see?
I see what I think is a big black speaker and then like a plastic tub with something stacked.
Yeah, with a glass of
And
some
then
kind.
a glass with something.
Yeah, I think it's a straw.
A straw. Okay. Yeah.
Before we play it, what do you think is going to happen?
I don't know. We're talking about sound, so something with the speaker.
So they're going to put sound in their speaker. What do you think is going to happen to the straw? What do you think is going to happen to the glass? Yes, Mr. Kevin?
I was thinking something to do with a motion back and forth.
You mean vibration? Vibration.
Moving back and forth. Ooh.
Ooh, because sound creates vibration.
It does.
Let's watch it.
Okay.
What do you notice? What do you wonder? What are you thinking? I will tell you, they're turning up the sound coming through that speaker. Wait a minute.
Ooh.
Oh.
Oh.
What?
A dancing straw. Straw. Oh.
Wow.
Write it down. What did you notice? What are you wondering?
Wow.
Mr. Kevin, what did you notice or wonder?
Well, I wondered what was going to happen with the straw, and it danced so much that it jumped right out of the glass right before the glass shattered.
Pretty cool, huh?
Man, it was very cool.
I was expecting the glass to tip over, not to break.
Oh, you think it like vibrate and
I
tip
thought it would
over.
just, yeah.
What about you at home? That shattering was amazing.
It was.
Nobody touched it, nobody hit it. So what caused it to shatter?
I saw the person in the background plugging their ears.
I wonder if the sound got really loud. Wow.
Yeah,
That's pretty cool.
it is.
All right.
Oh,
How does sound react when we change a variable? So someone was changing a variable there. They didn't change the cup or the straw. They just turned up
the volume.
the volume or the, I'm not sure because I couldn't hear it, what it was, if it was intensity or volume. What happened? Well, it went from not moving to vibrating more and more and more and more and more, so much
then-
that the glass shattered.
It's pretty wild. Should we review our, yeah.
I was just going to say, so teachers, you remember when we were talking about amplitude?
Yes.
So when the volume increased on that speaker, that was the amplitude
Oh, because
increasing.
it was the amplitude was increasing because it gets louder. And
Yeah.
do the waves get
So
deeper?
the waves get taller and taller.
That's how loud it is.
That's how
And then
loud it
this
is.
is the pitch.
And that's the frequency, right? Frequency or
Pitch?
pitch.
Okay.
Amplitude.
Yeah.
Pretty cool.
Really cool. Let's review our
Okay, hang on. Almost
You can
there.
just say it.
Big science word.
woo,
All right, vibration.
vibration. A moving
Movement
back and forth. We learned that a decibel is a unit for measuring the volume of sound.
So I have to tell you something really cool.
Yes.
On our little TV over here, this is new. I don't know why it's there today, but we have this little volume meter that goes up and down, and it tells us all the decibels. It has the decibel measurements. So when the little line goes up, we know how loud we are. Maybe he put that there so we don't scream.
We don't scream, which I did. I woohooed.
Sorry, Mr. Kevin.
Sorry, Mr. Kevin.
That was a loud
Pitch.
woohoo.
Is the tone of a sound, is it high or is it low?
And then we learned to amplify is to make larger or greater.
And amplitude is the loudness or softness of the sound.
Today we're going to learn a new word.
Variable.
It was in our essential question.
It was. What is a variable? Well, vary. Like I think like to V-A-R-Y, vary means like to differ.
That's what I was thinking is when we drive over the mountains, there is a variable speed zone.
And speed can change.
Speed can change.
Okay.
So that's what I was thinking, like
Maybe
change.
something that changes? Okay, what's the definition?
Something that can change or that has no fixed value.
Like the amplitude is a variable.
It can change.
The pitch is a variable. How much water we put in something is a variable.
Yes.
How thick something is a variable. It's something that can change.
The material of the glass, they chose glass, but they could have put plastic in there.
Yeah, I wonder what would have happened with plastic. Maybe the straw would have just danced and the plastic wouldn't have broke.
Yeah, I don't know.
Maybe it would.
Our sentence is, in science, we change a variable to get a different outcome.
So we change something to see if something different happens. We're going to be doing a lot of that today.
And it's important as scientists that we only change one thing at a time.
Right, because if you change two variables at a time, then you're not going to know which
Which
variable
one?
it was that caused the problem.
Okay, oh, we have a fun new science graphic.
Oh, yes, this is so great. We've been spending a lot of time in that pinky red area, asking questions, doing reading, getting knowledge about the subject,
Making observations.
making observations, and now we're going to move down into the green. We're going to do some experimenting, and we're going to do some hypothesizing. If I do, then will happen. And a hypothesis is like a prediction of what you think is going to happen based on the knowledge you have, and then we're going to test it out.
or gather data.
Gather data and see if that's actually what happened.
And then we can form a conclusion.
Ooh.
Which is where we say, because,
Happened.
Yeah.
Okay.
Oh, here we go.
We're not going to redo the speaker
We're not.
experiment. Here's the thing, friends. I thought we were. I couldn't get it to work at home. We couldn't get a speaker. today, so we have some other experiments to do.
Yes.
Would you put, Mr. Kevin, you can just do straight on to us now.
I will.
Okay.
Oh.
So the first one we're gonna do is the one that's right in front of me. You'll notice that there, and I'm gonna give you this so you can take some notes.
Wonderful.
You can write down some of the observations.
Okay.
You'll notice that there are some glasses and some water. So all the glasses are the same. They all have the same amount of ratio to water color. But what variable did I change? What's different about each of these glasses? What's different? What is the thing that I changed from this glass to this glass? This glass to this glass? This glass to this glass? And this glass to this glass? What did I change?
I know.
What did I change?
The color.
I did change the color, but I put the same amount of color ratio to water.
Oh. So the color is not a variable that would
No.
impact.
Mm-mm. I did the color so we could see the different colors,
Okay.
so we could see the heights of the water.
Okay.
That should be a clue.
Oh.
Did you get it, friends?
I
What
hear
is it?
some of them saying it.
What is it?
There's different amounts of water.
There's different amounts of water, and I used a tablespoon, and I put 4 tablespoons, 6, 8, 10, and 12.
Okay.
So I made my variable between each one the same amount,
Okay.
so that I was controlling my variable.
Okay.
Important in an experiment to control your variable. I just didn't like dump some here and some there and say, oh, that looks about right.
Okay.
So now what I'm going to do is I'm going to take a pencil and I'm going to hit the glasses. Now, before I do it, what's your hypothesis? What do you think is going to happen? Thinking about what we know about sound and sound waves and vibrations, that the larger the waves, the lower the sound. The closer the waves, the higher the sound. Which one do you think is going to be the highest sound? Which one do you think is going to be the lowest sound? And you can use the color. That's why I did the color, so you could easily make observations. Mr. Kevin, could we get some think time music while they're doing it?
Yes, of course.
All right. Miss Allison, what do you think?
I think the glass with red, which has more water, will make a lower sound. And the glass with blue, the least amount of water, will make a higher sound.
And what are you basing that hypothesis on? It wasn't just a random guess. What are you basing it on?
I was thinking about the wavelengths and the wavelengths of the sound and how we know that a lower sound, the what is that word again? Is it the frequency in between?
In between the sound waves, Mr. Kevin, is that the frequency?
That's the frequency.
The
Yes,
frequency.
you're right.
If they're farther apart, it's a lower sound.
Okay.
And I just kind of thought those would be farther apart.
Okay. Shall we try it?
Let's try it.
Which one do you want me to do first?
You choose.
Okay.
Can we listen to just the red and the blue?
Yeah. Why? Why do we think this one is lower and this one's higher?
I don't know.
Because this water slows down the waves. And there's only this much glass to vibrate through, right? So it's going to be a slower wave that's further apart. This has lots of glass to vibrate through, and it can go really, really, really fast.
I'm writing down what you said.
Isn't that cool? Mm-hmm. Could you hear it okay, Mr. Kevin?
Absolutely, yeah.
Awesome.
And I thought, so I don't know if you're going to cover this. I think you probably will. But the last two glasses that are so close, I think it might have something to do with the highest pitch that the glass could possibly make.
Yeah, it's actually these two that sound really close.
Yeah. Yeah, the two middle
These
ones.
two. And then this one goes.
Yeah,
It
he's
goes
definitely
high.
higher.
So we were trying to figure out why, and I added a little bit of different water. I made it a little bit more drastic in the water, but it didn't change. So we're wondering if it's something to do with the glass.
Yeah.
Oh, yeah.
Like maybe this glass, when it was made, is a little bit thicker than this glass is.
Right.
Oh.
So if it's just like a
Yeah.
hair thicker, it's going to be the same vibration, right?
And that's a variable that we can't control.
I can't, and it does sound a little bit different, but it's just like,
It's really subtle.
barely, it's really subtle.
Yeah.
So that's something you can do at home. Find some glasses, put different amount of water. You can play them. If you have bottles, you can put different amounts. Well, my tongue is really causing
Tripped
problems.
over it.
You can put different amounts of water and then blow.
Oh yeah, that's
and it'll
fun.
make different pitch sounds.
That's
It's
really
pretty fun to do.
Make sure you ask an adult first.
Yes. Yes,
And-
Mr. Kevin.
And one more thing you can do, you can moisten your finger with some of the
can.
water in the glass and rub it around the rim.
Right. If I could take my mask off, I could do that. But
Yeah. Well,
You know what I could do?
Just put your
Just dip
finger
it in the water. Yeah.
Yeah.
no, it's not going to work. I don't have the time. Okay. I'm going to move these off to the side. And we're going to do another experiment. Now, this one I thought was pretty interesting, and I'm not sure if it's going to work with our masks on. I'm going to find out. So, Mr. Kevin, can you zoom in on the top of these just for a moment?
Sure.
So as you can see, yeah, that'll be a good shot. As you can see, there's rice on the top of these, and I'm actually going to put this underneath in hopes that you can see that rice a little bit better. So there's rice sitting on the top of both of these. You can, there we go. I've got glare going on. You see the
I
rice,
see,
friends?
yeah.
Rice and rice. Now, what do you think's going to happen to the rice if I start singing or humming at the bowl? And if I have to take my mask off, I'll have Miss Osmond step off
Yeah.
screen to do it. But what do you think's going to happen? Go ahead and take some think time. What do you think's going to happen if I start humming or singing or talking towards the bowl? I'm going to get close. I'm not going to touch it, but I'm going to get close. What do you think's going to happen to the rice?
And that's a saran wrap.
It
or
is.
Something like that, right?
Yeah, it's really
Cling wrap.
tight
Yeah. Cling wrap over the top
with rice sitting on top
with
of it.
rice on the top of it.
What's going to happen to the rice?
I've got a great side shot too.
Okay, awesome.
So
Oh,
be able
yeah,
to
that'll
see
be
the-
perfect when I do it.
Nice.
when you start.
Okay, Miss Oslin, what do you think's going to happen to the rice?
So, because I was thinking about our other experiment with the speaker
Yes.
and the water and the salt, and I remember that when we played the music, the water and the salt, or the tone, excuse me, it wasn't music, the water and the salt moved.
It vibrated.
Because I know that, I think the rice will also move.
Even though I don't have sound coming up through the bottom? Mm-hmm. Shall we try it? Mm-hmm. Okay, Mr. Kevin, let's
Okay.
do the side shot.
Okay.
Did you see it moving?
Yeah.
Lower pitch, higher pitch. That's neat.
Cool.
I
Now we
even
have
heard the rice rattling
You could hear it, couldn't
on
you?
the, on the surface.
It was vibrating and moving back and forth.
What if we move the towel?
Ooh, let's move the towel.
I wonder if that changes anything.
Let's see. No.
Not really.
But what if we use a metal bowl instead of a glass bowl? So what variable are we changing?
The material of the bowl.
Material, because sound travels differently through different materials. What's happening is the sound is traveling through the glass and then vibrating that plastic, which is causing those rice. Now, I don't know. I haven't done it with a metal bowl. Let's see what happens.
Did it move more?
Yeah, because my high, I got this one to move.
You
Did you see it?
did.
Oh, it didn't do it that time. They're moving a little bit.
Yeah, that one even spun in a circle.
Wow.
So I'm going to make a prediction, and I'm going to hypothesize based on that. That sound travels better through this type of metal than through this thickness of glass. And I'm making that hypothesis because these moved better than these did. And I know that metal is a good conductor. Pretty cool. So if you want to try this at home, you could get a plastic bowl, you can get a glass bowl, whatever bowls you have adults' permission, put saran wrap and put like rice or salt, and then see. Maybe get a speaker
Oh, yeah.
with some music and
That would
put it
be
up
neat.
next to it and see if it dances and
See what
changes.
happens.
Pretty cool. Okay. Last one.
Oh.
Now this is the one that I'm excited for.
Yeah, it's gonna be really fun. So I saw this last night, and they actually used a shoebox. Now I had this little box at home that we could use, so I brought this. I didn't have a shoebox. You could use a shoebox, a cereal box, a plastic box, like if you have one of those plastic storage boxes flipped upside down. This box is hollow inside.
Oh.
You see it hollow right there inside. All it is a box, a rubber band, and 2 pens. The pens lift the rubber band off the box. So I'm going to play this tone. Can you hear that, Mr. Kevin?
Yeah.
What do you think's going to happen? Write it down. Can I do that? So I went from this and now I'm going to move it to here.
So the variable that you're changing is the distance between the pens.
Yes. What's going to happen when I shorten the distance between the pen to the pitch of the sound? Thinking about sound waves. It's going to have the same amount of vibration happening. I'm not going to change the amount of vibration I'm giving it, but the distance that vibration can travel is shorter. What's going to happen to the pitch? Some think time music? Okay, Miss Haslem, when you're ready. She's writing a ton. She has a great idea, I think.
Well, I also included the because.
Ooh, even better.
Shorter distance.
What do you think's gonna happen?
Okay, when we change the distance between the pens, I think the pitch will be higher because the sound waves will have a shorter distance to travel.
So it's gonna take those longer sound waves and it's gonna squish them together to
Yes.
make them closer together, so the frequency is gonna be quicker?
Yes,
Should we try it?
yes.
Well, I'll go back where I was so we can hear it. want to go higher?
Yes.
Sounds like a very out of tune guitar.
It does.
Okay,
Try plucking downward.
that's better. Ooh, but it moves my
Moves the
pens.
pens.
There we go.
There we go. That sounds like a ukulele.
It does.
Little
Watch
bit.
what happens when I do this.
That was neat. That is so fun.
How cool is that?
Very cool.
So as these are wider, there's more space for that vibration to travel. You can see, Mr. Kevin, can you show them close on the rubber band?
Mm-hmm.
You can see the vibration of it.
Yeah, you can.
And it's like, whoo. I wish I could do it in slow motion. But then when you go here, see how fast that's going?
Mm-hmm.
It's really tight too, like it doesn't move very far.
Mm-hmm.
But here, much,
Wow.
much deeper wave and much.
I wonder what would happen if we changed the thickness of the rubber band.
I wish I had a thicker rubber band. I might have a thinner one. Here's a thinner one, so we'll put both of them on here. And let's see if either of them sound different. Oh yeah,
It's like the strings on a guitar.
yeah.
Oh, interesting.
Can you hear it, Mr. Kevin?
Yeah.
So the thinner rubber band has a lower sound.
Because think about a rubber band that's thicker, it's going to take more energy to move that rubber band. So those waves are going to be lower frequency or higher
High
frequency,
frequency.
because it's harder to move it, and then this one's easier to move. Yeah.
So I'm not quite sure that that is conclusive, and here's why I think that. Knowing what I know about guitars
Yeah.
and guitar strings,
Yes.
what produces the lowest sound
Is
on
a bigger
guitar?
string.
The bigger string.
So that's weird.
Oh.
Yeah. So
I wonder
think,
why.
Well, we might have the experiment might be a little flawed.
Well, yeah, because I'm
that
using
we're
rubber
flawed,
bands.
But yeah, these are just rubber bands on a box. So
I wonder if it has to do too where it's placed on the box.
could be where it's placed on the
Oh.
Because it's placed where there's less place to move sound. You know what? This rubber band's a lot looser than this rubber band.
So that's
Yeah.
another variable to think about.
So this is why you only want to change one variable, because
Yes.
now we're like, oh shoot, which one is it? Which variable is
Yeah.
it? So really, I think the variable that changed, because the thickness of these rubber bands isn't too different, but this is, look how much stretchier this is to this one.
box. Yeah.
It's
Right.
way tighter. So this is going to be able to produce a lower sound because it's going to be able to have a bigger vibration. I think that's more the case than the size of the rubber band. What do you think at home? What do you think the reason is this one's lower and this one's higher, based on what we know about sound? Miss Austin and I don't know everything about sound. We're learning a lot along with you, which is the great thing about being a teacher.
I know, it's fun.
So we did some changing variables today. We changed how much liquid was in a cup. We changed the
Material.
the material, thank
of
you,
the bowl.
that the sound is going to travel through. And then we changed the distance between, and then we changed how tight the rubber band was. Pretty cool. So how does sound react when we change a variable? Well, how does it? That's going to be your job. So today, you're going to write or sketch a diagram or write a poem,
Oh, that'd be
or
neat.
you get to get creative. But you're going to go on to Flipgrid, which is a new thing we're doing. You get to go on to Flipgrid.
Yes.
I've given your teacher a link, so hopefully they'll give it to you. You'll go on there, and I'm going to have a question for you, and it's going to be about what does sound do when we change a variable, and you can even try an experiment at home and show us. So you can take
That
a
would be
video,
amazing.
you can post a picture, you can just write a comment. You have to tell us something about how sound changes when a variable changes. And and then you post it.
You could also write it down and send it to us here at our
Yeah.
TV classroom. Mr. Kevin, how can our fourth graders send us their hypothesis?
Just email TV Classroom at tacoma.k12.wa.us. You can also send us something in the mail to the classroom headquarters here, 601 South 8th Street, Tacoma, Washington, 98405.
Thank you,
All
Mr.
right.
Kevin. Now it's time for our affirmation.
I love affirmations. You know what? Whenever we go on field trips, we always forget because we don't have our affirmation slide.
I know.
It's a good reminder.
It is. Let's think about what would be a good affirmation today. Mr. Kevin.
I am an excellent observer.
Ooh,
Good one.
that's a good one because you really had to observe today to notice what was happening.
We had to look at some really small or subtle details. Okay, let's all take a deep breath and say our affirmation. I am an excellent observer. Excellent job today, fourth graders. We hope you have a great rest of your day, and we look forward to seeing you next time in our TV classroom.
I'll see you on Flipgrid. Bye.
Rules. 1. You have 10 seconds to pick your crewmate. 2. A new timer will appear with an exercise for the crewmate you picked. 3. You will get points for each correct crewmate and exercise you choose. 4. You will get bonus points if you find Maui's hook. 5. If you pick the imposter, you will lose all your points. 6. Use your math skills to see how many points you can get. Good luck.